A galaxy just blasted its neighbor with a beam of energy. Another launched a jet 3 times the size of the Milky Way, and then a ripple in spacetime was tracked from the dawn of the universe to long after its end. This last month, the universe got stranger. I'm Adrienne, and in this illumination, we're shining light on 5 recent space discoveries that quite honestly stopped my scroll. Not just because they were strange or beautiful, but because they make you pause and rethink what's really out there. From cosmic violence to perfect symmetry, from gravitational echoes to stellar nurseries, here's what the universe revealed last month. Let's start with a galaxy that might be targeting its neighbor. This one, quite honestly, stopped astronomers cold. While observing 2 galaxies drifting near each other, scientists noticed something definitely unexpected: a sharp, narrow stream of radiation extending from one galaxy straight into the heart of another. It looked like a beam, an energy jet focused and aimed directly across space. Now, galaxies interact all the time through gravity, tidal disruption, and even slow motion collisions. But this looked deliberate, or at least directed. The larger galaxy is likely home to a supermassive black hole that is actively feeding. This is what astronomers call an AGN, or active galactic nucleus. These black holes are surrounded by swirling disks of matter and can launch high-speed jets of charged particles throughout their poles. What's so unusual here is the alignment. AGN jets usually flare outward into space, but this one lined up perfectly with a neighboring galaxy, as if it was trying to punch a hole straight through it. And that's not just being dramatic, it is potentially devastating for that other galaxy. These jets carry enough energy to heat or strip away star-forming gas, so this blast might be halting stellar birth in the galaxy that it's hitting. I guess it's kind of a galactic sterilization. Either way, it's the first time we've captured this kind of one-way energy transfer between 2 galaxies so clearly. And while the mechanism may be natural, the effect feels almost surgical. This brings us to an even more massive outburst, one that spans across galaxies, not between them. Astronomers recently observed a black hole jet so enormous it spans a distance 3 times the size of the Milky Way. It's coming from a quasar named J1601 plus 3102, an active galaxy from the early universe with a supermassive black hole at its core. What we are seeing is a relativistic jet, a beam of charged particles launched at nearly the speed of light. These jets form when magnetic fields around a spinning black hole whip plasma into tightly focused streams that erupt from the poles. In this case, the jet stretches for over 1,000,000 light years. And here's what's wild. Because this quasar is so far away, the light we're seeing left more than 12 billion years ago. This is one of the oldest and largest black hole jets ever detected, a kind of cosmic time capsule. Even stranger, one side of the jet seems to vanish. That's likely due to something called relativistic beaming, where light from the side moving away is stretched out and dimmed almost to invisibility. So not only are we seeing a structure larger than almost anything we've mapped, we're watching how its motion can distort our perception of space, of scale, and speed. Its light might be from a time before our solar system even existed, but that's not stopping it from showing just how powerful this jet truly was. Up next, our discovery is about something quite a bit different. After these last 2, you are probably envisioning a cosmic mess out there in space, and in general, you would be right. Yet now we turn our attention to something clean and perfect, something that feels almost designed. Astronomers recently discovered what may be the most perfectly round structure ever observed in space. It is a massive radio-emitting shell that is nearly flawless in its symmetry. They are calling it Helios, Greek for perfect or complete. At first glance, it looks artificial. A glowing ring so smooth, so evenly distributed, it does not match the usual chaos we would expect from cosmic explosions. But this is not alien technology or some unknown device. Scientists believe it is a supernova remnant, the expanding shell of gas left behind after a massive star exploded. Now, usually those remnants are lopsided, jagged, or warped by their environment. But this one didn't collapse into chaos. It held its shape perfectly. That raises questions. Was the surrounding space unusually uniform? Did the explosion happen in an undistributed cosmic pocket? Or is this just a rare moment when nature aligned everything exactly right? Even its brightness is evenly distributed, meaning the expansion did not just start symmetrically, it stayed that way. It's a structure that does not just resist disorder, it seems to defy probability. And while the origin may be natural, the result feels strangely deliberate. Now we shift from something unusually perfect to a ripple that travels through time itself. Let's set the stage. Imagine a ripple in space-time, one that forms before the first stars light up the sky, then flows through the warped geometry of a black hole and continues long after the galaxies have gone dark. That's exactly what physicists have now simulated for the first time, a gravitational wave's full journey through a black hole's space-time. Gravitational waves are caused by colossal events, like black hole mergers. Using advanced computer simulations, researchers tracked a gravitational wave as it traveled through a black hole space-time before, during, and after it encountered the most extreme curvature in the universe. Now, normally, models focus only on the brief burst we can detect, the moment of collision. But this new work zooms way out, showing what happens across cosmic time, from the infinite past to the infinite future. As the wave approaches the black hole, it stretches, compresses, and distorts, not just in space, but in time. It's like watching space-time itself breathe. The simulation shows how the wave bends through intense gravity, then continues its journey across the cosmos. This kind of modeling is incredibly complex. It requires solving Einstein's equations across vast timescales and through some of the most extreme geometries in the universe. But it's more than just a technical feat. These simulations let us test general relativity at its limits, and it may even point the way toward a deeper theory of quantum gravity. We've seen gravitational waves shake the universe before, but this is the first time we've followed one from the beginning to the end. Now we turn to an image, a single frame capturing the ancient past of the universe, sculpted in gas, dust, and light. The James Webb Space Telescope has just taken its deepest look yet into the cosmos, focusing for over 120 hours on a galaxy cluster known as Abell S1063. Located 4.5 billion light years away, this massive cluster acts as a gravitational lens. Its intense gravity bends and magnifies the light from even more distant galaxies hiding behind it. In this resulting image, we can then see the arcs and smears revealing impressions of galaxies that existed more than 12 billion years ago. These are glimpses of the cosmic dawn, when the first galaxies were just beginning to form. JWST combined 9 separate exposures across different near-infrared wavelengths to create this view, revealing details we've never been able to study at this resolution before. By analyzing these ancient light signals, astronomers hope to better understand how the earliest galaxies formed, evolved, and clustered in the young universe. Because the deeper we look, the more space reveals itself as a kind of cosmic memory, a record of the universe's earliest moments, still arriving as light. Okay, every one of these discoveries pulls back the curtain just a little more on what the universe is and what it's still becoming. This last month, space gave us plenty to think about. We started with a galaxy jet so powerful it may be halting star formation in its neighbor. We saw one black hole's energy beam stretching over 8 million light years across the cosmos. Then came a supernova remnant so symmetrical it's redefining what we thought was possible. We then learned about scientists that tracked a gravitational ripple across the entire timeline of a black hole's spacetime. And we just ended with the deepest look yet into the ancient universe, where galaxies stretch like memory across time. The more we discover, the more it feels like we're only scratching the surface. Each of these stories opens up something bigger about time, about matter, and about how much we still don't understand. And if you enjoy content like that, I can't wait to see you here again. If any of these discoveries shifted your perspective or gave you some new insight, we would all love to hear about it. Which one and why? All the links are in the description below if you want to explore anything further. Thank you for being here. Until next time, stay curious and take care.